Wireshark is free, open source, and the world's foremost network packet analyzer. And it is the de facto standard across system and network administrators. Wireshark has the ability to listen and record traffic, as well as advanced filtering and reviewing options. We're not going to do a deep dive into Wireshark right now, since that's the subject of network layer attacks. So here, let's see a summary of the traffic and the systems related to the interfaces we listen. Let's go to Kali and start Wireshark. You can start Wireshark from the Applications menu or open a terminal window and type Wireshark to start the app. Don't worry about the ampersand and the and of the command. Putting an ampersand at the end of a command causes the shell to run the process in the background. It's sort of multitasking. You can have many processes running, but only one in the foreground at any given point. The process in the foreground is the process that appears to have locked up the terminal. Whatever. The first message is because we are a super user on Kali. No worries. Okay, the welcome page of Wireshark asks which interface we would like to listen to first. So let's have a look at the interfaces of our system. To look at the interfaces and to remember the IP address of Kali, open a terminal and type ifconfig. There are two result sets of the ifconfig command, eth0 and lo. eth0 is the first Ethernet interface. Additional Ethernet interfaces would be named eth1, eth2, etc. Here we have only one. Now lo is the loopback interface. This is a special network interface that the system uses to communicate with itself. eth0 is the interface that we're interested in at the moment. Double-click to open the eth0 on the main page of Wireshark to start capturing the packets passing through our Ethernet interface. Now, to speed it up, let's create some network traffic. Open one of my virtual machines, OWASP BWA, and ping Kali. To stop ping command, press Ctrl-C, ifconfig, to learn the IP address of the machine. Now I go to another VM, Metasploit, and ping the last VM first. And then ping Kali. Here we have a lot of ICMP and ARP traffic at the moment. So let's generate some traffic. I open the browser in Kali and visit the website served by the OWASP BWA machine. And even more traffic. I visit nhs.uk, my favorite website. Okay, that's enough. Let's turn back to Wireshark. As you see, we have a lot of packets captured, and new packets arrive every second. ARP packets, TCP packets, TLS packets for HTTPS traffic, etc. Here we don't investigate the packets in detail. We want to learn about the systems which are interacting with us. So go to Statistics menu and select Conversations. There are 5 tabs in the Conversation window by default. And we're on the IPv4 tab at the moment. Here there are IP packets grouped by address A and address B. In each line, we see how many packets sent up to now, total size of the packets in bytes, number and size of the packets from A to B and from B to A, etc. There is traffic between 8.8.8.8 and my Kali. Now I know that 8.8.8.8 is the IP address of Google DNS, so I must have set the Google DNS as the DNS of my Kali. You know, I'd like to look at the network config. And yes, my DNS address is 8.8.8.8. In the Ethernet tab, we can see the MAC addresses of the systems. The addresses full of Fs mean that the packet is broadcasted. ARP requests are the examples for these kind of packets. In the TCP tab, we can see TCP packets grouped by the addresses and this time by ports as well, because a system may have different interactions with any other system. For example, Kali may have HTTP traffic through port 80, and at the same time, it may have an SSH connection through 22 as well. Same as TCP. Packets are grouped by IPs and ports in the UDP tab. Here we have learned a lot of live systems, IP addresses, and MAC addresses just listening to the traffic go through our network interface. If you'd like to investigate the traffic between the two machines, select a line, right-click. If you choose Apply as Filter from the menu, only these kinds of packets will be seen in Wireshark. I'll choose Find at this time. As you see, automatic query string is prepared. I can navigate between the packets by clicking the Find button. Go back to the conversation window. At the bottom right, there is a Conversation Types button. When you click on it, a lot of different protocols are listed. These selected 5 are the default selected protocols. You can add any protocol from the list. When you select one of them, a new tab is added to the conversation window.